I have 9 digits, 0, 1, 2, 3 till 9, and I have to form 6-digit positive whole numbers by arranging these 9 digits. The first condition is that all the digits have to be distinct, so no repetition. So how many ways can I do it? It's a 6-digit number, so the first place cannot be 0. So it can be any one of the 9 digits. Once I decide the first place, the second digit can be in 9 ways because now 0 can be included, then 8 ways, then 7 ways, then 6 ways, and then 5 ways. That's it. All the 6 digits are formed. Another way to think of is the first digit is in 9 ways, and then out of the remaining 9 digits, I have to arrange 5. So 5 out of 9 are to be arranged because I have only 5 more places left. So that's the total number of positive numbers that are formed. The second thing is that they have to be distinct and the digits have to be in the ascending order. So what should you do when they are? So say the first digit can be any one of the 9 things, right? Okay. Once you choose that, depending on, say for example, the first digit was 1, then how many digits are left from which I can choose the rest of the digits if they have to be in ascending order? It cannot be 0. If it has to be 1, then I have 8 more digits left from where I can arrange. So 5 out of the 8 digits can be arranged. Or if it is 2, then 0, 1, 2 are gone, and out of the 10, so 7 digits from which I can choose. Or if it is 3, then 6 digits from which I can choose, and if it is 4, then 5 digits. Oh sorry, it's P, not C. I don't have to just choose, I have to also arrange them. That's it. Beyond 4, I cannot form a number because the remaining digits cannot be in ascending order. So this is the number of possibilities for digits to be distinct and in the ascending order. So here if you see, the possibilities are or because one of them will happen, and that is the reason we are using a plus sign, whereas in the earlier case it was first place was 9 ways and all other places are in 9p 5 ways. So the and became multiplication. Second question, I have 8 runners who are competing in a race, and obviously each one of them will have a place. A and J are 2 runners such that in condition A, J has to finish immediately after A. Okay, so how many possible positions can the runners have? Out of the 8 runners, 7 runners are the only ones where I can decide, because A's position is almost decided. Once you know J's position, A is after J. Therefore, I have to arrange only 7 factorial ways because I don't have freedom to really choose the 8th one. It's fixed. Next is, what if J is just after A? They are not saying immediately after A. It is after A. So where can A be? First of all, if J is in the sorry A is in the first place, then I have 7 ways to choose from for J. If A is in the second place, I have 6 ways. If A is in the third place, I have 5 ways, and so on till one place. And once I choose the position, how many runners do I have to arrange? 6 factorial, because A and J are already arranged once I do this. I'm fixing A's position and deciding how many choices do I have for J's position, because J has to be after A. Once I do this, and I have to arrange the remaining 6 runners. So and 6 factorial. This is the OR condition, because only one of them will happen and the arrangement will happen. If you look at the previous question, I'm already arranging also. 8p5 when I do, I'm not just choosing the position, I'm also arranging them, all the digits, and that's the reason I didn't have to do this into 6 factorial. Here I'm first choosing where J will be placed based on where A is, and then I'm arranging the remaining runners. That's the difference between the previous question and this one. So read it carefully and understand how you want to solve that particular question. Third, I have 12 teachers. Out of them 7 are male and 5 are female. Now a group of 5 have to go for dinner. So how many possible groups? So first question is possible groups if more male, if male has to be greater than female. So how many people are there? 5 people. In 5, if one of them has to be greater, that means I have to have all 5 male and 0 females, which means I will select from all 5 from men and 0 from women, or I will select 4 from men and 1 from the women, or 3 from men and 2 from the women. Beyond that, they will not have more males than females, and therefore this is the only possibility of choosing this, making groups of 5 where more males and females are there. Then so if you want to find the final answer, 7c5, 7c4 is 35 times 5 plus 7c3 is 35 times 10. That's your, add them then. The next condition says 2 teachers out of these 12, Gary and Gerwin, they refuse to go. So how many possible groups can be formed? Whenever there is these 2 are to be removed, it's best to look at the possibility when they go and remove it from the total possibility. So if there were no restrictions, out of 12 teachers we had to choose 5. See, we are not arranging, because we are just collecting a group of 5 and sending them for dinner. In what order they are selected, it doesn't matter. That's why it's choice. So it's combination. If Gary and Gerwin definitely go, then I have to select only 3 more teachers out of the 10. So this is the possibility when Gary and Gerwin will go. So if I subtract that from the total possibilities, I will get the possibilities when they will not go. 7c5, can do it on the calculator. See, wherever the numbers are difficult to compute, they will give the sum in calculator, but you will have to show the method, and only then. That means either C with it combination or is it permutation. You'll have to write that, then do it on the calculator. Okay. Next is a slightly easier question. So these are all past paper questions only. The easier ones come in section A in paper 1 when the numbers are easy. Otherwise, in section A in paper 2. Section B, if a permutation combination question comes, it will come in combination with probability. It will not be single on its own. So 15 boys and 10 girls in a line, and most of these are 5 to 6 marks based on the number of steps. If part A, B, C are there, that is how it will be decided whether it's, but most of them are 5 to 6 marks. So 15 boys and 10 girls are to be arranged in a line with separate groups for boys and girls. So one common line, but separate groups for boys and girls. So if there was no restriction, 15 plus 10, 25 have to be arranged, means 25 factorial. However, here what I have to do is, I have to think of all 15 as one group, all 10 as one group, and then I can say that these 15 within this group can be arranged in 15 factorial ways. These 10 can be arranged in 10 factorial ways within them, and they can be interchanged. So therefore into 2. So 15 factorial into 10 factorial into 2 is your final answer. It's a big number, but that doesn't matter. You will get it on in the calculator if they are expecting you to write the final answer. The next part says 2 boys and 3 girls are selected to go to theatre. They are selected, which means combination. In how many ways can I make the choice? So 2 boys out of 15 and, isn't it? Because they're together, and 3 girls out of 10 are to be selected. In how many ways can they be selected? Because the selection is happening together, that's why and, which means multiplication. If you do this on the calculator, this is the answer that you will get. Okay. Another question that one of your classmates, Aditya, had already asked me this in the class. So I have a sheep pen, okay, where there are 6 pens in a bigger region, but I have only 5 sheep, and they are to be arranged in these pens. Now what is the statement is that each of these 6 pens can hold all the 5 sheep. Okay, it means the choice of the pen can be repeated for all the 5 sheep, isn't it? It's like saying that the digits can be repeated when I'm forming a number, a similar kind of a question. So the first sheep can be put in 6 ways. The second sheep can also be in 6 ways because I can repeat that pen. The third sheep also in 6 ways. Fourth sheep also in 6 ways, and fifth sheep also in 6 ways. I can put it in any one of the 6 pen. So 6 raised to 5 is all the possibilities of arranging these sheep. This is arrangement because each thing is a new one. Now the condition is A and B cannot be together. So what are the total arrangements now? If A and B are not to be together, it's difficult to now see where all can they be. That's very difficult. But can I know when can A and B be together? So if A and B are together, that means they're counted as one thing. So I really have to arrange only 4 sheep now, because A and B will be counted as a single object. So if I look at the same kind of a logic, now they will be arranged in 6 raised to 4 ways. But these are all the places when A and B are together. So when will they not be together? From the total possibilities, if I can remove this. Okay. The next condition says that each A and B cannot share a boundary, and each sheep have to be in only one pen. One pen, one sheep. Now, where all can you place them? So let's draw this arrangement again. A and B cannot share a boundary. So say supposing A is here, then B cannot be here and cannot be here. B can be in any one of these 3 places. So when A is in a corner, I have 3 places for B. However, A can be in this corner, this corner, this corner, or this corner. So I have 4 places in which A can be, and in each of those 4 places I will have 3 ways in which B can be. Once I have arranged A and B, how many places will be left? Out of 6 pens, 2 will be used by A and B, So 4 are left. And how many sheep are left? 3 are left. So 3 out of the 4 places, 3 are to be arranged. So 4p3. 3 sheep in 4 places. That's another way of saying it. So that's one thing. A can be in any of the 4 corners, or look at the other arrangement possible. A can be either here or that, and then B cannot be here, cannot be here, and cannot be here. So I will have only 2 places for B. So whenever A is in the middle, so in how many ways can A be in the middle? 2 ways. Then how many ways can B be arranged? 2 ways. What about the remaining sheep? Again 4p3. Because after A and B are arranged, there are no restrictions for them. So the total ways are 4 times 3 into 4p3 or 2 times 2 into 4p3, which means 16 times 4p3, which is 384. 4p3 is 4 factorial. So 24 into 16. Okay. Next question. I have again cards with these numbers written on them, 1 till 9, and I am selecting 4 cards randomly. Whenever they say randomly selection, no, so I'll assume that they are being simultaneously selected, and therefore the digits cannot be repeated. Now, how many possible selections can there be? So they are not saying arrangements, okay? How many possible selections can there be if 5, 6 or 7 is the largest integer possible? So out of my 4 cards, my largest number on the card will either be 5 or 6 or 7. So if the largest digit is 5, how many digits do I have to select from? 1, 2, 3, 4. How many cards do I have to select? Only 3, because 5 is already selected. So 4C3. Out of 4, 3 are to be selected. Or if 6 is the largest digit, I have 5 digits from where 3 cards are to be selected. Or if 7, then 6 cards from which 3 have to be selected. And the total is 34. That's the first part of the question. The second part says, in my 4 cards, I need at least 2 even digits. At least 2 even. That means out of the 4 cards, 2 can be even, or 3 can be even, or 4 can be even. First of all, let's find out how many even are there and how many odd. So 1, 2, 3, 4, 5, 6, 7, 8 and 9. Odd numbers are 1, 2, 3, 4 and 5. So 5 odd digits and 1, 2, 3, 4 even digits are there. So if I want at least 2 even, so either I can choose 2 even and 2 odd, or 3 even and 1 odd, or 4 even and 0 odd. Add everything. '81 ways of doing it. Here it was only selection. They are not asking you to arrange them to make a number or anything. And that is the reason we are left with only that. Okay. I have a word Sunday and I have to make 4-letter words, combination of words. So 4-letter words are to be formed from Sunday, and they need not be correct in English and all that. So we are assuming the first thing is no restrictions. I can just choose any 4, but I have to not only select 4, I have to arrange them also, because I'm forming words, right? So it's about arrangement as well. So how many letters are there? 1, 2, 3, 4, 5, 6. 4 out of 6 are to be arranged. So 6p4, not choice. Another way somebody may say that I will first choose and then I'll arrange. Both are the same. 6c4 into, so if you write the definition, this is same as 6p4. So you'll get the same answer. The next question says, at least one vowel must be there. And they are also to be arranged, no? So it's not just about choice of vowels, it has also to be arranged. So therefore, you cannot think of saying, okay, I'll look at one vowel being selected. Then it's not just about selection, I also have to arrange. Then that will be a little tricky thing to think of, how to arrange them with A being selected or then with U being selected. A and U are the only two vowels there. Instead, I already know part A is without restriction. If no vowels are selected, that means I'm only arranging 4 letters out of 4. If I remove them, obviously I'll get the arrangements. Just think about this. If you think of arranging vowels, first of all you have to choose, and then it is not very simple to think of all possible ways of arranging after selection. It's easier to actually remove the possibilities when vowels are selected. The next is the vowels must be together. So vowels must be together and both must be selected, and both selected. Now what should I do? So if out of the 4 letters, 2 are already vowels, so 2 more letters only I have to select. Out of the remaining 4, I have to select only 2 more. So I can, after I arrange these 2 letters, the vowels can be here or here or here. These are the places for the vowels. So in any, because they have to be together, they have to be around the 2 letters. So I have 3 ways, and between vowels they can be interchanged. So I can write AU or UA, so therefore 2 ways. And I am arranging the remaining 2. So once I arrange the 2, I will, by arranging 2 out of 4, because I have 4 letters left, right, after I remove the vowels, which out of those 2 are you arranging? That is the reason there are so many combinations. 4p2, it's not just selecting, you have to select and arrange them, and therefore 4p2. After you arrange these 2 letters out of those 4, there will be 3 places around those 2 letters where you will place these vowels together, because vowels, 2 vowels are now considered as a single object, and within the 3 places the vowels can be interchanged. So 3 times 2 times 4p2. 4p2 is 6, 3 to 12, 3 to 6, sorry, 4p2 is 12, so 72 is. Okay. Next, 5 digit, okay, this is the word. I have 5 letters and I have 2 digits, COVID-19. And the first is arrangement. So I am counting arrangements when 19 appears, 1 and 9 appear together and in the same order and in that order. So I cannot say 1-9 or 9-1, both are together, no, because the order is also restricted. So there is nothing that I can do for 1-9, it has to come as it is. So this 1-9 will be counted as a single object, And then how many letters are there? 5 more letters are there. So these 5 letters plus this 19 together form 6 objects. 6 objects can be arranged in 6 factorial ways. That's the first thing. So I have to arrange this COVID-19 with 19 being together and in that order. Next is all the 5 letters must be together. There is no restriction on this 1 and 9. So now 1 is an object, 9 is an object, and these 5 letters together as an object. So together 3 objects are to be placed, which is the 3 factorial ways. But the 5 letters within themselves can be arranged in 5 factorial ways. So it's just a coincidence that I have got both as 720. They are not the same answers. Next is only 5 letters are used. Only 5 letters are used. And D will be placed after C. They are not saying immediately after C. It will be placed after C. So if C is in the first place, then D can be placed in, I can choose any one of the 4 places for D. If C is in the second place, I'll have 3 ways in which I can choose. If C is in the third place, correct? Once I place C and D, I have how many letters to be placed? Total 4 factorial, isn't it? Once I choose the place, then C is fixed and D is fixed, sorry. So I have 3 factorial ways of choosing the remaining letters. Okay, next question. I have a clock on which all the numbers are written 1, 2, 3, 4, 5, 6, 7, 8, 9 till 12. Okay, 10, 11, 12 and 1. So all 1 to 12, all the numbers are written on the clock and each number is connected to all other numbers using lines. How many lines in total are drawn? So from 1, 11 lines are drawn. From 2, only 10 more lines are drawn because 1 and 2 are already connected. From 3, 9 lines. Then 8, then 7, 6, 5, 4, 3, 2 and 1. It's actually sum of an arithmetic progression. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 5.5 into 12. You know, in arithmetic progression there are n by 2 pairs of numbers which have the same sum, right? That's what I'm using the logic. u1 plus un into n by 2 is 66. Another way to think of is, whenever I have to draw a line, I need 2 points. So every time I'm drawing a line, I'm actually choosing 2 out of 12 points. So the number of ways in which I choose 2 out of 12 is the number of lines I can form. That's also 66. And the last question, we had done a similar kind of a question in the class. This is mainly, I mean, this may not come in this PE because it also involves some knowledge of probability, but it's mainly binomial expansion, so I'm trying to help you understand this. So Jack and John are playing a game, and the game is to roll the die 7 times, and Jack wins. Jack will win if John will roll 1 or 2, and John will win if Jack will roll 3, 4, 5 or 6. Can you tell me the probability that Jack will win? John should get either 1 or 2. That means there are 6 possible things that can come on a dice, and out of 6, these 2 possibilities will make him win. So 2 out of 6. So 1/3 possibility that Jack will win. If I don't think draw is possible, then the remaining 2/3 chance John should win, and also if you count 1, 2, 3, 4 out of 6 is 2/3. So that means there is no draw at all. Either John will win or Jack will win. Now the first thing is the probability that Jack will win the first 2 rounds. What is 1 round? 1 round is rolling the die 7 times. Sorry, 1 round is rolling the die and I am rolling it 7 times. So what is the chance that Jack will win the first 2 times? Jack winning is 1/3 chance. So out of 7 chances, I have to win 2 times. But in what order can I win? Can Jack win like this? Jack, Jack. And then the rest 5, John will win. John, 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 John and John. Or I can have Jack win the first one and the last one and the remaining. So there can be several ways in which Jack can win. So if you remember your binomial distribution formula, it used to say NCR A raised to n minus r times b raised to r. So NCR used to tell me in how many ways can this happen. Same thing here. In how many ways can these 2 games happen? 7C2. 1/3 should happen twice and 2/3 should happen 5 times. Why 1/3 should happen twice? He should win 2 rounds. That means he should not win the remaining. That means John should win. So winning 2 means he should win the first time and the second time. That's why it's squaring. And winning 5 times means first time and second time and third time and fourth time and fifth time. So 2/3 raised to 5. So very similar to the binomial expansion formula if you see. So it's 1/3 plus 2/3 are the A and B values and raised to 7. How many ever times you play, the total probability is always 1. That's what it is telling you. Okay. For each game, what are the possibilities? Winning or losing. There's no draw. So for 7 games, how many possibilities are there? For 1 game, 2 possibilities. For 2 games, win, lose, lose, win, 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 lose, lose. 4 possibilities. For 3 games, if you write like that, 8 possibilities and so on. So for 7 games, 2 raised to 7, 128 possibilities are there for a game to happen. 128. What are those 128 possibilities? I can have Jack win 0 games and John winning all games, or Jack winning 1 game and John winning, or 2 games or 3 games or 4 games and so on. What should this add up to? If you look at this, this is the binomial expansion for 7CR, R equal to 0 to 7. Your A and B are 1 raised to 7 and 1 raised to 7 minus R. So it is 1 plus 1 raised to 7, which means 2 raised to 7, which means 128. So what this 7C0 plus 7C1 plus 7C2, all this are adding up to 128, which is the number of possibilities, correct? So your 128 is nothing but 7C0 plus 7C1 plus all the way till 7C7. Number of possibilities of the game, winning or losing. Okay. Now, if they play 2 rounds, I mean 2 times 7 games, and Jack wins 5 in the first round and 2 in the second round. Can you write how this possibility will be? So out of 7, Jack has to win 5. But in how many ways is that 5 out of 7 possible? That's 7C5. 1/3 should happen 5 times and 2/3 must happen twice, because Jack is winning. Jack winning probability is 1/3, right? Let's look at it. Jack winning is 1/3, yes. So Jack must win 5 times in the first round, and he must win twice in the second round. If we combine, 7C5 is same as 7C2, and if you look carefully at the other multiplication, I'm getting 7C2 the whole square or 7C5 the whole square, 1/3 raised to 7 and 2/3 also raised to 7, which means 7C2 the whole square times 2 raised to 7 and 3 raised to 14. In general, if I had played, like, instead of 2 rounds of 7 games each, if I had played multiple, if I had played like n rounds, what will in general be the situation? And he will win r games and lose n minus r games, so 7 minus r, so winning will be r games winning and 7 minus r games losing. So I will have 7CR the whole raised to n, because I'm playing n rounds. So in each round, how when I'm playing it twice it became square, 2 raised to and 3 raised to 7 into n. This will be in general the, and again this may not come in your exam, but in general you can think about this as a binomial expansion used in case of games where only 2 possibilities are there, winning and losing.